Okay, so we're moving on to the next section. You can think of these fractions here as a kind of division. That's kind of really what we were doing. We were dividing down when we simplified these algebraic factors in a way, because that's really what we're going to talk about doing now. Is we're going to reintroduce the division symbol, but really it's the same as what we were just doing. Okay, remember 11/4 is the same as this here. A couple of terms here. So what we talk about is the dividend, the thing that we're dividing, divided by the divisor or the divisor, sometimes people call it. And you might remember from primary, perhaps, talking about, well, 2 goes cleanly into 11. Okay. So this one here, the quotient, you might have heard of this as being. And what's left over is 3. Well, what does rem stand for? It stands for remainder. So what are we talking about here? Well, it's a little bit like this, isn't it? We had 2 left over with the remainder 3 that still needs to be divided by 4. That bit's not finished yet. So as much as you would have done this lower down in the school, we're going to do this now, but we're going to do it with algebra. Okay, so we're going to get a part that's sort of finished and has been divided, and then we're going to get a bit that's left over, our remainder, that still needs to be divided. And the way that this kind of works in the book is you get lots of exact answers with no remainders to begin with. And then later on, it moves on to questions where there's a remainder. Okay. So if you've done this before at Further Maths GCSE, you might be very comfortable with this. For other people, you're going to need to practice this quite a few times. Okay. But it's very much one of those things where once you get it, you get it. Okay. So here we go. Here's the question. Question is x cubed plus 6x squared plus 5x minus 12 over x minus 1, to make a link with what we just did earlier. And we've set this up as a long division problem. So the first one, I'm going to just sort of talk through what happens with you, but then we're going to do a couple of examples nice and slowly on a whiteboard. So we have our dividend, which is the long polynomial, the x cubed one, so order 3. And we have our divisor, which is x minus 1. So what are we going to do? Well, again, if you know your long division from numbers, this will be easier. If not, don't worry, just go slowly and feel free to pause the video. What we do is we start off with our biggest powers, okay? And divide just the first term. Okay, I believe that's meant to say x. I don't know why that says x squared. So what we're going to do is we're going to say, how many times does x fit into x cubed? Fit in, I'm using the language of division here, aren't I? Well, it fits in x squared times. And you check your answer. This one here, multiplied by this one here, should take you back to this one, which it does. Okay, great. And what we're going to do, let me just check. Yeah, okay, I'm going to do this a little bit differently in a moment. In fact, I would actually recommend lining the powers up when you do this, but we'll go ahead with this just for now. So x goes into x cubed x squared times. What we're going to do underneath then with our long division is we're going to sort of write out now what the term at the top multiplied by each of these things gives us, and then we're going to take that away. So x squared multiplied by x gives us x cubed. We know that because that's why we put x squared there in the first place. But what's new is I've got this term over here. How did I get this? I did x squared multiplied by minus 1. So I'm using the other bit now, okay? Not just the bit at the front, I'm using the other bit as well. And that is minus x squared. And notice that I line up the columns with the powers, okay? After that, there's nothing to do. There's no other terms left about this and this here. So what we do is we subtract. So we do this multiplied by everything that's there. X cubed minus x cubed, you'll notice now there's a gap. There's nothing left there. 6x squared minus x squared is 7x squared. Okay. What Watch out for double negatives. That's probably the number one mistake in this. Okay, it's always subtracting on this line here. So you always do what you had originally, subtract all of this part here. And for the other bits, really there should be a minus 12 there as well. And for the other bits, you just copy them down. Nothing happened with the 5x and nothing happened with the 12. So you just move them down, copy any signs. Okay, what do we do then when we're at this part? Well, this is an algorithm and we just repeat the algorithm. So what did we do? We said we look at the parts with the highest powers, that's this and this, and we ask ourselves, how many times does x fit into 7x squared? It fits in 7x times. Give you a moment to have a think what we're going to do with that information now. Look, we've still got a lot of space under here, so what are we going to do? Well, now we take this and we multiply it by this part. We write it underneath. But we also take this part and multiply it by this bit as well. And you should keep getting the same terms here, because those should sort of disappear, and then you'll get different terms in the second part most of the time. Okay. What do we do then? Then we subtract this part again. So 7x squared, that's going to be gone. 5x minus 7x gives you 12x. And the minus 12, yeah, you just fill that gap in. You keep that moving down. Almost done. 12x minus 2. Repeat the process for a third time. So how many times, looking at the biggest powers of x, how many times does x fit into 12x? It's 12 times. When we get this bit up here, we will multiply it again by this and by this. So it will give me 12x. I should get the same term again. And then it will give me minus 12. We do this minus this. 12x minus 12x. Well, if you have something and you take away that thing, it will be gone. If you have something and you take away that thing, it will be gone. So this actually has no remainder. Okay, you can divide x cubed plus 6x squared plus 5x minus 12. You can divide that by x minus 1 and there'll be nothing left over. In other words, the remainder is 0. Okay, that's kind of the remainder. So what that means is I could say that x cubed plus 6x squared plus 5x minus 12, that's actually, I'm even going to use the identity sign here, that's exactly the same as saying, in fact, let's just keep it as an equation. It's exactly the same as saying x minus 1 multiplied by, well, the thing that you've just found out, which is x squared plus 7x minus 12. So quite a neat result. In other words, we can take cubics, which are much more difficult to deal with, and we can break them down into friendly parts, like a linear part and a quadratic part. So let's do another one here, and we're going to do this one on a whiteboard. So here we go. So the question is 6x cubed divided by x plus 5. So what are the steps? First step is look at the highest powers. X, how many times does x fit into 6x cubed? It fits in 6x squared times. And notice I'm doing this slightly differently to the slides now. I'm putting the x squareds together. I think this is good practice to line up your powers. So 6x squared is sort of the first part. Now, when you have this bit here, you multiply it by these and you write them underneath. So 6x squared multiplied by x should be 6x cubed. That's why we chose it in the first place. 6x cubed multiplied by 5, well, that's going to give me 30x squared. The other part I don't have anything for. Okay. Now, we always subtract. So 6x squared minus 6x squared, there's not going to be anything there. 28x squared minus 30x squared, I will get minus 2x squared. Okay. Copy the other parts down. You can copy them all down. I think it's fine to just do that. And we repeat again. So we're looking at this part here now and this part up here. So how many times does x fit into minus 2x squared? It fits in minus 2x times. So when I have this over here, I multiply by these parts. If you're starting to feel this is a bit repetitive now, that's good. It means you understand what you're doing. So minus 2x multiplied by x, minus 2x squared, and minus 2x multiplied by 5. So that'll be minus 10x. Again, should get the same terms here. When we subtract, there's no need to do this bracket thing. I'm just sort of doing that to make it a bit clearer. But we always subtract. That's going to disappear, and I'm going to get minus 7 minus 10x. In other words, plus 10x. So 3x plus 15. Okay, last time. How do I know it's the last time here? Well, I know it because of the powers, okay? 3x and an x, I know I'm going to get a 3, but I know I won't be able to go down any lower than that, okay? So 3x and x, well, it's going to fit in 3 times, which will be 3x, and 3 multiplied by 5 is plus 15, and what do you look at that? It happens that they both cancel, so my remainder is 0. In other words, I'm finished, okay? And lots of the book questions don't have a remainder to start with. However, it's not always like this, okay? So what you could do is you could say 6x cubed plus 28x squared minus 7x plus 15 divided by x plus 5 equals 6x squared. Can you see a shortcut here in getting the 6x squared? 6x squared minus 2x plus 3. I just want to show you while we're here, what would happen if the remainder were not 0? So let's just make it up. Let's pretend, okay? So just going to pretend. I know that 15, take away 15 is 0, but let's pretend it was 5. If I had 15 minus 5, I would have 10. So I'm pretending that I had 10. What would you do in this situation? Well, 10 would still need to be divided. You still need to keep doing the process. Yeah? So you'd have to do 10 divided by x plus 5. Well, we haven't really talked about how to handle this situation. Okay? So actually, that's how you would leave it. If you had, I'm just pretending here, if you had a remainder, well, the meaning of a remainder is that, you have a number, you have a remainder even, which is 10, and that still needs to be divided. So you would just have this extra bit here at the end. Okay, that's what it would look like. There we go. Okay. Should we do one last example? Yeah. In fact, let's go through this one. I think because I think you would have got the idea. Let's just show you the animations for this one. This one's interesting because it talks about how to handle when you've got missing powers. So look at this one. It's got x cubed and then an x, and it misses the x squared. So all you do for this one is you put your 0 in. Okay, it's really important that you put a 0 in. So don't do this. Don't be lazy because you'll just lose marks. It's false economy. Yeah, put a 0 in when you've got missing terms. And it will just mean that somewhere in your working out, you will do like 0 minus 3. Okay, it will just mean that you interact with 0. But everything else is actually the same. Interestingly, notice this one, there's a remainder, isn't there? There's a remainder of 5. So the answer is going to be, when you divide it, you'll get 3x squared plus 3x plus 1 plus the bit that still needs to be divided, which is 5, still needs to be divided by x minus 1. Okay. One last one for you there with I think this one is with a remainder. Okay, so just pause the video and have a quick go. And let's just check. So we should get a remainder of minus 6. Okay, it's not the whole fraction when they say a remainder. It's just sort of the numerator. Yeah, -6, which still needs to be divided by it, but the remainder is the bit on the top. Okay. Yeah, and all you really need to do for this is just take a bit of time, set your working out, and don't forget to watch out for the double negatives. Okay, that's where you're most likely to make a mistake.